Welcome back to our system design series. Today we are going to explore an incredibly important component of almost every system, databases. Whether you are designing a simple application or a complex distributed system, choosing the right database and understanding how it works is fundamental to your systems to success. So, what is exactly a database? A database is essentially a structured collection of data that allows you to store, retrieve, and manage information effectively and efficiently. Databases are the backbone of any data driven system, enabling application to handle everything from user data to inventory record to transaction histories, and also choosing the right type of database depends on the specific needs of your system and how you plan to use the data. So let's try to make a small system. It's a pretty simple one. We will have a client. Let's make this smaller. And this client will send requests to the server. Let me delete this. This is from the old video of the cap theorem. And the server will send read and write requests to our database. Okay, but right now, it's okay. So right now we need to know what type of database should we use. If we talking about what type of database, we mainly talk about two things: a SQL database or no SQL database, and no SQL. Okay, let's start with the SQL database first. The SQL database, I would say that in your system design, by default, you go with SQL databases. These are relational databases that store data in tables, which are linked through defined relationships. And SQL database uses structured query languages, which is SQL, for managing and querying data, and they are ideal for systems that requiring consistency and strong consistency and complex queries. And popular SQL databases include like MySQL and also Postgres. And yeah, let's say that this is the two most important. Postgres. Um, yeah, PostgreSQL. Also, they are a great choice when your data is structured and relationships between entities are important, like a financial system or a traditional e-commerce platforms or a health system when consistency is really important. So second, we have NoSQL. NoSQL databases, these are non-relational databases that offer more flexible data modules, such as key value pairs, documents, graphs, or wide column stores. NoSQL databases are designed for scalability and high availability, making them ideal for applications that need to handle large amounts of unstructured or semi-structured data. Example for NoSQL database, it will be MongoDB, and also it will be like Cassandra, Redis, etc. Like there's tons of different things. So NoSQL database is a good choice when your data model is more dynamic or when you need to handle large volumes of data with minimal latency, such as social media app or real-time analytics. So let's try to understand sorry, when to use SQL and when to use NoSQL. So I would say by default you go with SQL, and this is because of SQL are they were like they're working for 40 years. They can handle a lot of stuff, and also they have what we call asset properties. The asset properties, it's for atomicity, consistency, isolation, and durability. So if your application needs asset properties, you will likely lean towards an SQL database, as these properties ensure data integrity, which is crucial for use cases like banking or booking system or health system or e-commerce system. On the other hand, if your system prioritizes scalability and availability, I would say NoSQL will be the choice, because NoSQL was built to scale horizontally, because it's a pretty important thing to understand about NoSQL. Um, NoSQL databases are designed to be horizontally scaled or horizontally scalable, meaning you can add more servers to handle more data and traffic. This horizontal scaling capability is a key reason why NoSQL databases are often used in distributed high traffic applications. And I would say, yes, you can actually do something like that in NoSQL by sharding, but we will talk this in later videos. But for now, let's understand that NoSQL database tend to has a horizontal scalability um, nature with it. So let's try to consider a real world example. Imagine you have, like, for example, like a social media platform. We have tons of clients. Okay, we have a lot of clients and a lot of users that will create posts and and I'll send tons of requests to our server, and our server will send the reader and write operations to our DB. Okay, DB. And right now we need to know that all of these, like, imagine that again, like, users are constantly posting updates, committing, liking, and sharing the content. In this scenario, you need a database that can handle massive write loads and scale easily as your user base grows. I guess a NoSQL database like Cassandra or MongoDB could be a good fit because of their ability to handle large volumes of data across distributed nodes with high availability. However, if you're building a traditional e-commerce platform, maintaining data integrity like inventory counts or transaction histories is critical also, and SQL database might be a great fit for that. So in addition to SQL and NoSQL, there are also newer databases technologies like new SQL, which aim to combine the scalability of NoSQL and the asset properties of SQL, providing middle ground solution for modern application. But I would say that I have never seen anything about the new SQL database types in systems and interviews. So we just I just said it to so for us to understand. So that's it for this video, and in the upcoming video we'll take like a deeper look at the relational databases and why they are so important. After that, we might talk about sharding and replication, about this further in future, because we have to talk about multiple database types that you would likely use them in your system design interview. So if you like this video, make sure to subscribe and hit the notification bell so you never miss a video, and see you guys in the future.